Hello everyone, welcome to the inaugural development log update video for the Anti-Extinction by Furr-Tec Studios. We have a plethora of exciting information to share, so let's dive right into the key topics we'll be exploring today. A quick heads up, this video is a bit lengthy, but rest assured, it's packed with in-depth technical explanations and insights from our journey at our own GDC, marking a significant milestone as the first full furry game studio for the fandom.
Hello everybody, welcome to our Furr-Tec Game Developers Conference keynote. In this video, we're going to be talking about a lot of the specifics regarding the game technical side of things. The next video we'll be uploading will be all about the story. And the next video after that will be all audio direction. And then the final will be updates to the company and things that have been occurring since we first started this company back in 2022 and up to this very moment, 2024. So, welcome to our first GDC conference for us. This will be way different from if you ever watched the video from GDC 2017, 2018, 2019. We'll be doing a video similar to that in VR chat, as you guys can see right now. So in this video, we're going to be covering a lot of the topics regarding technical side of development. So engine stuff, rendering, mechanics, code, multiplayer, basically everything you can think of. In this section, we're going to be going over the things that we have planned for this year, 2024 and beyond. Here's a roadmap of what we're going to be doing. So up here on the screen, as you guys can see, we have a little preview of our roadmap, not to scale or dates at the moment. So in this screenshot, we have Q1 through Q4 for this year, and then Q1 through 3 for 2025. As you guys can see, we have a lot of things planned for this year, a lot of programming overhead and a lot of technical side to deal with. So first, some of our first priorities will be overhauling our audio system to use Fmod, leveraging it for its expansion to mini games while looking at other solutions like Wise. But for now, we'll be using Fmod due to its simplicity of UI and workflow. Next up, we're also working on porting a lot of our model textures to DDS and TGA, while keeping copies of our PNG texture for development usage and ship DDS and TGAs in production. This leverages a lot of the good benefits of DDS and TGA. So DDS will be directly uploaded to the GPU, no Unity conversion required, while TGAs will be used to be for like norm apps. So this will be a two-level process. So Unity imports, conversion, upload to the GPU. So with that being in mind, we'll be also keeping copies of PNG textures for our development usage. So this will be used for development purposes. So you guys will not see any PNG textures in the final game. You'll all will see just TGAs and DDS. We're also leveraging our new DevOps version control called Diversion Dev, which is what we're using for this right now. As we can continue just on board without having to pay a kidney in a hard to use something like Classic A.C.E, which at the moment it's $260 per user per license, and that can add up very quickly for a studio like us with over 31 people on the team. So for the moment, we'll be using diversion.dev. Has really good some features, but sadly it's not quite up to par as Classic A.C.E, but we'll do our best to use it. And if that fails, we'll just switch back to Classic CM, but use the cloud version instead, so we can only have to pay $7 per user and not $260. So Classic on the other side of things will be our backup solution for the game. So that was synchronized with our Diversion Dev code base. This will basically ensure that if Diversion Dev gets somehow corrupted, we have a second backup solution for the game, so we don't lose any progress. On the programming side of things, we're also going to start formatting our structure of code to follow a more guided rule set and naming scheme to help speed up development between the two new coders we have recently acquired last year. We're also helping to deliver a more pleasant debugging experience, so if we ever encounter issues with the game, errors, warnings, whatever, it'll be much easier for us developers and you, the consumer, to tell us, okay, this is where you have issues, this is how we can address them quickly in this new debugging experience pipeline. Furthermore, let's introduce our new and improved A.C.R and A.C.E features. So for many of y'all who are not up to date with our programming schedule on Discord. A.C.R is basically our rendering engine, so this just renders everything. And then we have ACE, which is basically the module that houses all these components of the game engine. So ACE, it's called the Aether Chaos Engine. And A.C.R is called the Aether Chaos Renderer. Two different things, but they both function on one module, which is the ACE engine. So on the left, we have A.C.R enabled, and on the right, we have the Unity umbrella rendering system. On the left, we have A.C.R enabled, and on the right, we have the Unity rendering system. You guys can get a clear benefit performance improvement by analyzing both scenes. So on this side, on the left, we have A.C.R enabled, so this basically uses our front-end rendering technology. And on the right, we have the Unity umbrella system, which is basically their version of occlusion calling and rendering. In the pursuit for optimal game performance and overall aesthetics in Unity, we're changing the way we tackle this issue. So the way Unity typically renders things is whatever it sees first, and then if it's like a rock model, it renders that rock model in front of it, and then if there's rock models behind it, it's going to render those too. When that happens, we have something called Overdraw, and that's very bad for performance because the game is basically rendering things it doesn't see, and this introduces more batches calls to the game engine. So, with that being said, A.C.R has a new feature called Performance Boost Overhang. So this module basically simplifies the process of rendering terrain objects, even character models. So, like my character, you have the body mesh, clothing, and hair. It will only render what it sees first and not behind it. So this basically gets rid of that unnecessary overdraw. So the issues: performance overhead. Stacking models create redundant geometry, leading to overdraw on the GPU and a major hit on performance. This also affects light mapping. So traditionally, methods pose challenges for effective light mapping. It's crucial for achieving realistic visuals. So our approach would be very unique. So with our custom implementation of some Markov cube algorithms and some other technology, we're going to be basically eliminating altogether unnecessary geometry on anything we basically put the game engine to render. So A.C.R basically performs a throughout analysis, intelligently removing up to 60 to 75% of unnecessary triangles within a terrain or asset model. It also uses cell-based combining, so basically combines multiple things into a cell-based groups, renders that group, and then it pushes to the GPU to render, and you only do one draw call for that. So this drastically reduces draw call by adopting a cell-based combining approach, optimizing terrain for superior performance. Next, we have triangular efficiency. This only renders 1/3 of the original triangles, surpassing GPU instantaneously and in speed and efficiency. So this is basically our version of Nanite in Unreal, but in Unity in a much cheaper way. Next, rendering speed. We achieve 3-fold increase in render speed, significantly reducing GPU overdraw. This also improves our resource optimization. So for light maps, this basically means 3 times less texture space for that light map or texture in that memory space, reducing memory overhead. So the game will finally get a proper boost that it needs for when we introduce a lot of more complex geometry in the game later on in development. Next up, cellular collider efficiency. So along with this A.C.R implementation, this also integrates with terrain, voxel terrain meshes, and whatever not. So it also supports collision, so no more falling through the holes. Next, what do we get from this as developers? Well, we outperform traditional methods of GPU instancing and optimized draw call at the same time, achieving GPU efficiency. This also significantly reduces memory requirements, making the game much easier to run on much lower end systems. And it's compatible with many assets, not just our assets. So at some point in the game where we do upload people's avatars, like user generated content, the game engine will intelligently remove unnecessary triangles from rendering in the first place. So be on the lookout for that, because that is a major step for basically our version of for innovating. Along with the overdraw improvements that we did to the engine for rendering side, and the A.C.R, it just got support for clustered rendering. So this basically takes trillions, well, not trillions, realistically, well, thousands of lights, basically combining them into a single cluster. This basically improves a lot of rendering overhead. So instead of having 1,000 lights kill your FPS in a single scene, our version of this basically clusters all those light objects, combines them to one batch instance, and then renders that once and only once. Next up, we have a better noise filtering for this type of light clustering. So along with that, we have a rate marching algorithm being used to basically tell the lighting system how to accurately represent those lighting models based on real lighting data from the real world. So lights behave similarly to the real world based on inverse square law. This provides you with high fidelity lighting with no spatial limits or approximation noises. And it's made much more performant compared to traditional ray marching volumetric lighting algorithms. So this is based on a system called analytical approach, renders up to 1,000 volumetric lights at the same time, compared to SSAO. Now for ACE, Aether Chaos Engine, a new feature coming soon will be our dynamic resolution module, which will target FPS set by you. So if you want to target 165 FPS, the game will drastically, dynamically adjust the way things render in the game. So you can have more detailed volumetrics, less detailed volumetrics, and so on. So this doesn't just affect volumetrics, and it can also affect texture quality, model quality, and all that. So whatever you set it to, the game will change how it renders the scene so it matches that one target that you specify. I don't think any other game does this besides ours, so this would be a kind of cool thing to see how that works out for you guys. So this module is called the Chaos Dynamic Rendering SuperSampling Resolution. So kind of like DLSS, but it's not DLSS, and kind of like FSR. So this will monitor in-game performance in the background. Should it ever drop below the developer's specified target, it dynamically adjusts the rendering solution to restore intended performance. This feature is seen on consoles where if it's a heavy scene, the game engine will downscale various parts of the game to maintain a stable target frame rate. That's one key. There's basically zero trade-offs with the solution, and it strikes the balance between performance and visual quality. We also introduced alongside a sophisticated volume system, which encapsulates the volume zones for targeted optimization, offering precise control over performance parameters, assuring an enjoyable gaming experience.